One of the unsolved riddles of physics is the so-called three generations problem, which refers to elementary particles that seem to appear in 3 generations according to the standard model of particle physics. Following the explanation in Wikipedia, there are 2 types of leptons and quarks, which all are divided into exactly 3 generations or families. Between these generations, particles differ by their flavor quantum number and mass, but their interactions are identical. So each member of a higher generation has greater mass than the corresponding particle of the previous generation. It is uncontroversial that the 3 generations of elementary particles do exist. This has been proven by measurements. But scientists have no idea how this can be explained mathematically. There is no approach, no fundamental possibility to derive the masses of elementary particles theoretically. The particular count of 3 could not have been explained so far. But maybe it can be now. Dr. Norbert Schwarzer, author of the books Theory of Everything, A Fermat Universe, and World Formula, a late recognition of David Hilbert's stroke of genius, has published a series of papers in which he seems to have solved this mystic 3 generations problem. We are back again at his office on the German island Rügen and ask him in person. Hello Norbert, is it true? Have you solved the fundamental problem that has kept scientists all over the world so busy within the last century?
Hello Peggy. No, I have not solved this problem. Per definition, the solution to the 3 generation problem, well, it has never been properly defined, but there is an understanding among the scientists that the true solution to this 3 generation problem involves not just finding the reason for the fact that we have 3 generations, which I think I found a good explanation for, but also deriving the exact masses for those particles. Mm-hmm. And with this second part of the task, which seems to be the more difficult one, I still struggle. I have ideas where to look to find also a solution for this one, but so far I have to answer your question with a clear no.
Okay, so is this interview over then?
Well, it depends on your expectations. If you want to have an explanation for the reason why one could say that there is at least an explanation for the fact why we have 3 generations, then there could still be an interview.
Okay,
if you call this an interview at all.
Yeah, it sounds like a good chance. So could you please try to explain this for us?
Okay. It has to start and with an apology about the math to come. But without math, the whole explanation wouldn't be falsifiable. It would not be in a sense of defined by Karl Popper, true science. So math now. For all those who don't like it, bad luck, mates.
Oh dear.
So this is a metric. Usually a metric is being written with a small g and then these indices. I use a big G.
Excuse me, could you please write a little bit bigger for our audience?
You mean is that an elderly audience? Or?
Yeah, probably.
Well, maybe they should try wear glasses. So this is the metric, and it is being considered an adapted metric, which says we have a function. I already add something in here, a constant which belongs to the function divided by the mass, and this is being multiplied with an arbitrary metric. This metric should be can be a known one. It could be flat space, Minkowski metric, Schwarzschild metric, Kern metric, Kern-Newman metric, whatever it is. Charged particles, no particles. It could be a metric in arbitrary dimensions, whatever it is. And now I want to evaluate the Ricci scalar, which is a measure for the curvature, of the whole curvature of space and time described by such a metric, of this adapted metric. And because it is an adapted one, I give it this star thing. So, okay, the result of this calculation, which is a bit lengthy and cumbersome, pain in the, forgotten the expression, looks like as follows. So, at first you have this factor again, and we take the simplest case, which says, let's have this function f just be the small f cf divided by m, which is mass or equivalent to mass. Okay, so do not mix it up with the mass written with an e. Okay.
Okay.
Thanks for the same. Could be the same. It could be the same. It means politicians would like this because they would say they have to deal with methods just coming in 3 generations. But we mean something else here. It has to do with elementary particles. So, and we have this factor, but we have it to the power 3. This is just a result of this calculation, calculating the curvature, the scalar curvature of space and time in no matter what number of dimensions, no matter what metric it is, doesn't make a difference. It always comes out like this. And then we have a few terms and an operator, which is kind of a nabla operator working on this function f squared plus this factor again times the Laplace operator also working on the function f. So these are differential operators, and we do not care, not in this video and not with the elderly audience, not wearing glasses, about the structure of these differential operators. The important thing only is that they are defined by the metric. So they change with the metric you plug in here. But we always can assume, this is a well-proven fact, that it is usually possible to find eigenvalue solutions, which says you have a certain factor, we call it b here for this Laplace operator, times this function, and this is equal to the result of this differential operator. The whole Schrödinger, Klein-Gordon, and all these equations are built up like this. So this thing here is the Klein-Gordon or Schrödinger part, and this thing here is the Dirac equivalent. I know that Dirac usually started his approach with using the Laplace operator and splitting it apart. But you can get the same result from here. So in just one equation containing the Ricci scalar, which is the curvature of space and time, you have both the Dirac part and the Klein-Gordon part. It's all in one. And it's all metrically derived. So that's why theory of everything. We can have more complex structures, but obviously our quantum theory is built up upon a very simple form, namely just a scalar factor to the metric. Which means whenever space and time changes in volume, it does something quantum-like or quantum equivalent. And one of them things is mass. So this is Dirac, and we can always also find an eigenvalue a, and this time it's f squared because of the square here. And now have a look. This is just ordinary math. Where we have an algebraic equation of third order. third order. We have power 3, power 2, power 1. So, and how many solutions does a third order polynomial equation have?
3.
3.
Okay.
3. And these messes in here mean that always the combination, I need it down before you now, of a function we call psi here equal to m times f exists in 1, 2, 3 solutions for 3 messes and 3 functions. That's just it. That's just the metric outcome of this little transformation here. We call it a quantum gravity transformation of the metric because it results in the quantum equations, and this leads to an eigenvalue equation which always have, for simple algebraic reasons, 3 solutions.
And nobody has seen it before?
Maybe they've seen it, but it was too simple, obviously. But still, the task is now to have this and find out how to extract the exact mass values for the elementary particle. This means we need to find the matrix, and we need also to think about the structure, the mathematical internal structure of the Ricci curvature, of the curvature of space and time. I guess it's some kind of stable oscillations, wherever space and time oscillates volumetrically in a stable manner. We have stable masses. It changes its volume, whether permanently or in a kind of vibration, doesn't matter. We experience this as mass. That's just it.
So what's your next project? Would you like to try and define the masses, or is it for someone else?
It's always for someone else, as long as the other one is faster. But of course, among other problems I'd like to solve, I want to find the matrix being suitable for the description of the elementary particles. It can't be a flat space, because flat space is not charged, and many of the elementary particles are charged ones. They have spin and other funny properties, so these must all be mirrored within this metric. But that there are 3 generations, this question is simply answered, because whatever I do with a metric, the moment I give it the chance to change in volume due to the scale factor, it ends up in an equation like this, and this has 3 solutions.
Wow. Okay, that was in fact very interesting. So thank you, Norbert. I'm happy that you have had time for us today.
You're welcome.
And maybe we can meet for another session. I'm sure that you have a lot of more problems or more interesting facts that you could share with us, if you like.
Maybe also just for a cup of tea or something.
Yeah, why not? Okay, thank you. Bye-bye.
Bye.
Within the last 3 years, Norbert Schwarzer has published more than 350 papers, which all go down to very fundamental questions. For example, he has been able to explain Fermat's last theorem, but he's also dealing with quantum computing, artificial intelligence, socioeconomy, political decision-making, and other modern subjects. Norbert and his whole team can be booked for mastermind courses, consulting, problem-solving and troubleshooting in general, and all this in an extremely holistic manner.